All right, so before we went through the different ratios, now we're going to get into sine. And just like this is actually a lot like the tangent one that we just did, 9.2, you're going to find 9.4 is about cosine, and it's pretty much the same thing as well. You're going to find here we have a lesson about learning about the sine ratio and then the cosecant. So the relationship of sine and cosecant is just like the relationship between tangent and cotangent. They are inverses of each other, and then or reciprocals of each other. And then it says relate the sine ratio to the cosecant ratio. So that there you have it right there. They are reciprocals of each other. And then use the inverse sine. So the inverse sine function is basically the same thing as the inverse tangent function, where you know the ratio and you need to know the angle measure. So you're going to learn to do that in here. So this one I'm going to go through pretty quick because I think you're going to find, you know, you should be able to go through this problem or this set if you understood 9.2 pretty well, pretty quick. And if you didn't, you should spend more time on 9.2 to make sure you understand, and then you could get 9.3 and 9.4 pretty quick. So here we have right triangles. They're you know, they're showing it here. This is a golf club set on the ground, getting ready to hit the ball, and you can see that there is an angle here of the club face. And when it's set perpendicular to the ground, the club is set perpendicular to ground. The face goes off at an angle like this. And here we have three different angles, along with the measurements taken of the triangles formed by that club face. And what you want to, here it says, you know, how do you think the club face angle affects the path of the ball? Well, as it's steeper, it's probably going to go forward more. And as it's more laid back, it's probably going to pop up. Okay. And then you're going to write the ratios. And so with sine, the sine ratio, so remember me talking about some old hog came around here, took our apples, so some old hog. So the sine of this one is old hog, right? Opposite over hypotenuse. So, you know, the sine ratio is going to be, for 21 degrees, going to be equal to 19.3 over 54. And that's approximate based on measurements, you know. So you're going to recognize what happens to the ratio as the angle gets larger. So thinking about it, just imagine, you know, as we increase this angle here, well, you can actually just look, the angle's increasing. You can see that the opposite side is increasing significantly. It's gone up almost 20 millimeters, whereas this hypotenuse has only increased 8 millimeters. It is increasing as well, but the numerator is increasing faster than the denominator. So you should see that in the sine ratio, it's as the angle measure gets larger, it's increasing. Okay. Then the sine of an acute angle. Okay, so here's the definition. It's talking about it. You know, for angle A, opposite over hypotenuse, so it'd be BC over AB. They want you to calculate that and look at what they have in common. The idea is recognize that, you know, here's what June says. She's kind of made this recognition. The sine value of every acute angle is less than 1. Is June correct, and why? So thinking about that, the longest side in a right triangle is always going to be the hypotenuse. It's always the longest side. So you're measuring one leg over the hypotenuse. Can this number ever be larger or even equal to the hypotenuse? The answer is no. It's going to be smaller. So in this ratio, the hypotenuse will always be large. The denominator is always going to be larger than the numerator, so it can't get to 1, right? Because the opposite side, the leg, is shorter than the hypotenuse, so this is always a fraction less than 1. So June is correct. You want to explain that in there. And you should, you know, we already recognize what happened to the sine values. This is back there in question 3, I think it was, where they asked what's happening to the ratio as the angle increases. Go ahead and use this to calculate it. Don't forget to rationalize your denominators. And then you're going to, here we have we know that the sine is equal to 0.45. So if the sine is equal to 0.45, we can turn that into a fraction, which is 45 over 100. So if the sine of A is 0.45, what would the degree be? Now remember how we found the degree before? We used the inverse sine, right? So you would say the inverse sine of x is equal to, 45 over 100. So sorry, if you if you take 45 over 100, you take the inverse sine of 45 over 100, which is 45 hundredths here, you will get the degree measure, right? Because the sine of the degree measure of A is equal to 0.45, 45 hundredths. So the inverse sine of 0.45 will give us approximately the angle measure. Okay, cosecant. Cosecant is just related to sine in the same way. So let's look at sine again. So sine was opposite over hypotenuse. So now cosecant is going to be hypotenuse over the opposite. So it's the reciprocal again. It's the reciprocal. Okay, we're just taking the reciprocal of the sine. So the reciprocal of the sine is equal to cosecant, and you can plug in and do just like you did before. Think through the problems. The rest of this really is, we're going to use the inverse sine just like we did, where if you know the sine ratio, you take the inverse sine of that sine ratio and you will know the measure of the angle. And the rest of this, I'm really going to be done. I'm not going to walk through all this with you because you're going to use it the same. Oh, I guess I'll show you this last little bit. Sorry. But this is just really, I like this a lot because this exercises that starts here, on page 692. You have diagrams made for you where you can see there's two sides and an angle. And what you're going to do is you're going to recognize as you go through the problems that are found on page 693 and 694, there's 5 word problems. Each one of them has a diagram or a model that represents that word problem. So like problem A is talking about a building that's 80 foot high, and the observer is some unknown distance from the base of the building. And they look up at the top, they realize that there's an angle of elevation of 52 degrees. So out of all these diagrams, there is one that has a known distance for the height, right? And a 52 degree measure and an unknown distance to the base. And it's not A or B, so it's one of these. Now the reason I really like these, you're going to go through, you have to go through these, you have to match the diagram to the word problem, and then you use the diagram to help you solve the word problem. You got to figure out which function, whether it's tangent, sine, inverse tangent, which of those you're going to use to solve each problem. And really, the kids that are good at these kinds of problems are the kids that when they get the word problem, they create the diagram. They make a sketch. They say, okay, here's my building. This is my distance from the building. This is my distance to the top of the building. This here is the angle of elevation. And then they plug in the numbers and they realize this is what I'm missing. If you're missing this base here, this is the adjacent side to that angle. And if I'm missing the adjacent side, then I know that the sine of the angle is equal to the opposite side over the adjacent. So I could use sine of angle is equal to whatever length this one, in that problem it was 80 over x, right? So sine of this equals 80 over x. I can multiply both sides by x and I can solve it using basically your algebra. So I want you to go through these and get good at them. Make sure you're good at them. If you're not, make sure you spend some time talking to me, because these are the kinds of problems they love to throw throughout your college entrance exams, on your SBAC, the new ISAT, ISAT 2.0, the ACT, SAT, and everything else. And not only that, but they're also just kinds of real-world problems that are good to know. It's good to know this kind of stuff. So make sure you understand it well.